All right, so here we've got 2006 free response number 4, guys. This is non-calculator. So we have rocket A has a positive velocity, v of t, after being launched upward from an initial height of 0 feet. The velocity of the rocket is recorded for selected values of t over the interval 0 to 80. Yeah, that's why we got 0 to 80 as shown on the table. So part A, what we're supposed to do is find the average acceleration of rocket A over the 80 seconds. Okay? So, I want to find A, average acceleration. Alright, so guys, when I ask you to find average acceleration or average velocity, is going to be the other one they ask. There's really two methods. There's going to be FAV, and there's going to be AROC. And what it really comes down to is what information you're given, and you got to pay attention to your units. Okay, so for average acceleration, isn't acceleration feet per second squared? So my final units better be feet per second squared. Okay, there's going to be, like I said, two methods to find average acceleration, but on this problem, only one of them is going to work with our knowledge. So if we think about the FAV, let's say we integrate acceleration. Okay, and we'll do from 0 to 80 here. So if we integrate acceleration, isn't the other part of FAV having the 1 over 80 minus 0 out front? Okay, so think about our units on this. So this is really 1 over time. So this is going to be 1 over seconds. And we're integrating, well, acceleration is really feet per second squared. So if we integrate feet per second squared, that really is going to give us velocity, which is feet per second. Okay, so if we integrate acceleration, we get feet per second, but we still have this 1 over seconds out front, which my unit-wise will give me feet per second squared. Okay, that gives us the correct units we want. I also want to talk about AROC though. So AROC would be like if you took A of 80 minus A of 0 over 80 minus 0. Isn't that just like F of B minus F of A all over B minus A? So in this problem, up top you've got feet per second squared divided by time. If you were to use AROC here with acceleration, what you're going to get is feet per second cubed. Okay, which is going to have more to do.
3. There you go.
There we go. Which is going to have more to do with jerk, not acceleration. Okay, so we don't want the AROC here. We're going to want to use FAV. Let's also talk about doing these with velocity too. Okay, so if I were to do these with velocity, we're going to do FAV with velocity. So this is going to be 1 over 80 minus 0. Integrate from 0 to 80 of velocity, so v of t dt. Okay, when I do this, out front, this is really 1 over time. So this is going to be 1 over seconds. And we're going to integrate, well, velocity is really going to be feet per second. So if you integrate feet per second, what you're going to end up with is feet. We still have our 1 over seconds out front. So this is going to give us feet over seconds, which is a velocity. The other way we could be doing AROC is going to be with a velocity here. So this would be like v of 80 minus v of 0 divided by 80 minus 0. Now when we do this, velocity on top is really feet per second divided by time, which is seconds. So feet per second is really going to give you feet per second squared. Okay? So depending on what information you're going to be given is going to be which route you're going to want to go. We're not given any equations. Okay, so integrating acceleration or integrating velocity is definitely not going to be what we want to do. We're going to use our table data information here. Like I said, you guys have to pay attention to your units. All right, so we really want, what is this? Acceleration. So we really want feet per second squared, so this method AROC, or FAV, using acceleration. Okay? The other thing I want to point out, guys, let me erase some stuff here. So obviously we didn't want this one, right? That's jerk. This one gave us velocity. We're supposed to find the average acceleration. Okay, so we're going to use either FAV or AROC. Isn't this just the fundamental theorem of calculus, though? With FAV? Isn't this just going to be 1 over 80 minus 0? But here, if you integrate acceleration from 0 to 80, if you integrate acceleration, doesn't that give you velocity evaluated at 80 minus velocity evaluated at 0, which is exactly what the AROC version of it would have been over here? All right. So essentially we're going to do AROC. It's really the fundamental theorem of calculus. It's just kind of two different ways to look at it. But you have to pay attention to your units. Otherwise you're going to get average of some other thing you don't really want. Okay? So V of 80, we're just going to look at my table here. At time t is 80, we got 49. Minus V of 0, which is going to be 5. All divided by 80 minus 0, which is just going to be 80. Guys, this is non-calculator, so stop there. Okay? It does ask for our units. Well, if we're finding average acceleration, isn't that just going to be feet per second squared? Okay? Right, that should be an easy unit to figure out, because that's how we're figuring out which formula to even use in the first place.
Another,
Alright.
and another way to think about it is, if you think about AROC, right, it stands for the average rate of change. If you run the rate of change on velocity, you would get to acceleration. So if you're finding the average rate of change of velocity, you're finding the average acceleration. But the unit thing to like click that into place was really good, and like I didn't ever think about it this way. That like it's the same thing as FAV. So that's an interesting like thought. And definitely stop and just leave it with all your numbers and then the feet per second squared.
I'll also make some room here. Okay. So that's really all the work you need to do, guys. I just went off and explained that because we really haven't talked about that a whole lot.
And you got to have that difference quotient.
Yeah, make sure you're not doing that work in your head. I mean, obviously you guys are all smart enough to get 44 over 80, but you're not going to get the points or the credit for it unless you have the difference quotient. Okay, that's essentially just showing your work. And like I said, guys, this is not a calculator. You can just stop them. Okay. All right, so part B, using correct units. So you notice how in part A they said indicate units of measure. Part B, now they're saying use correct units. That is basically when you're going to get points for using units on your AP exam. Okay, they'll specifically tell you to use it. Explain the meaning of the integral from 10 to 70 of velocity. Okay. In terms of the rocket's flight. There's a second part to part B. You're supposed to use a midpoint Riemann sum with 3 subintervals to approximate what that is. Alright, so we first need to discuss what the meaning of this is. So remember, if you integrate velocity, it's not going to give you a distance. Okay, so this is really going to be kind of, technically this would be the displacement of the rocket from 10 to 70 seconds. But they're going to give you credit for also for saying total distance traveled, from 10 to 70 seconds because it says the rocket is going up. Okay, so this is going to be displacement or total distance of rockets. Okay, in feet from 10 to 70 seconds after launch. Okay, so I have basic displacement is being measured in feet from 10 to 70 seconds after being launched. That's kind of what you're going to need there. Like I said, distance is going to be acceptable here because the rocket's being shot up and it hasn't come back down yet. But technically, if you look at this should be displacement. Okay, remember if it's got the absolute values there on your velocity, that would be your total distance. All right, so now the second thing we need to do is approximate from 10 to 70 of V of t dt using three Riemann sums. Okay, so if I'm going from MRAM, so we want the middle value. So I'm going to go from 10 to 30, I'm going to go 30 to 50, and I'm going to go 50 to 70. So guys, I would definitely write that on my paper because now I realize I'm using my middle value for each one of these. Okay? When I look at this, my base is always going to be 20. 20, 20, 20. So I'm going to do 20 times something plus 20 times something plus 20 times something. Okay? So the values I'm going to be using here is going to be 22. Okay, I'm going to use the value at 40, which is going to be 35. I'm going to use the value at 60, which is going to be 44. All right, now my units on all this would be feet. Okay, because keep in mind, if you integrate velocity, you're going to get a distance. Our distance in this problem is just feet. Guys, you can stop there. Okay, don't keep going. You're only going to lose points. So I'm not even going to figure out what all that is. Okay, this is non-calculator.
You could also shortcut it since your base is always 20 and do this. And that's the same. But I would stop in either spot on one of those lines. So you're still showing a sum and a product. A sum of some products. That's what they're looking for on a Riemann sum, whether it's trapezoids or MRAM or LRAM or RM.
Okay, so there's not a whole lot of work for A and B, but C is going to be, I think, probably the hardest part of this. So C, rocket B is launched upward with an acceleration of 3 over the square root of t plus 1.
Rocket B? Now we have a rocket B, Mr. Herney?
Heck yeah, rocket B. So even though I say A of t equals that, guys, I'm just going to say AB of t is going to equal 3 over the square root of t plus 1. Okay, because now basically I have all these velocities that was referring to rocket A. Now I'm going to have a second rocket, and I'm just going to label everything with that as B. Okay. At time t equals 0 seconds, the initial height of the rocket is 0 feet. Okay, so I would also write down somewhere that SB of 0 is going to equal 0 feet. Okay, so that's going to be like my position of rocket B. And we know that the initial velocity of rocket B is going to be 2 feet per second. So VB of 0 is going to equal 2 feet per second. Which of the two rockets is traveling faster at time t equals 80 seconds? And explain why. So, this is all the information I have about rocket B. Okay? If I want to know which one's traveling faster, I really want to know the velocity at 80 seconds. So, considering rocket A over here, we know the velocity at 80 seconds is 49. So what we need to do is figure out rocket B. Is that going to be a velocity greater than 49 or less than 49? I don't have a velocity equation though for rocket B. The only equation I have is an acceleration. So if I want to find a velocity, I'm going to need to integrate the acceleration. Okay, so velocity of rocket B is going to equal the integral of my acceleration, which is 3 over the square root of t plus 1 dt. Okay, that is gross integration, I think. Maybe you want to do some u sub. So I'll just run through u sub real quick. I am going to bring my 3 out front though. Okay, I'm going to bring this guy up top. So to bring it up top, it's going to really be t plus 1 to the negative 1/2 power dt. Alright, we can do u sub. U is going to equal t plus 1 means du dt just equals 1, which means du equals dt. Okay, so as we go through here, we have v of b is going to equal 3 times the integral of u to the negative 1/2. Okay, dt gets replaced with du, so some simple integration. Okay, so now be careful when you integrate this. We add 1 to my exponents, so it's a positive 1/2, and we divide by the new exponent, so I'm really just going to be multiplying it by 2. We're integrating an indefinite integral, right? There's no boundaries, so you got to have your plus c. All right, so that means VB is going to equal 3 times 2 is 6. U, remember, is the square root of t plus 1 here. Okay, so now we can figure out my initial condition. V of b of 0 is going to equal 2, so VB of 0 equals 2, which is going to equal 6 square roots of 0 plus 1 plus c. So, isn't this going to be the square root of 1? 6 times the square root of 1 is still 6. So I just need to subtract 6 on both sides, so negative 4 is going to equal c, which means my equation for velocity of rocket B is going to be v of b is going to equal 6 square roots of t plus 1 minus 4. So we had to do all that work to just now plug in 80 for our time. So now we can figure out the velocity of rocket B at 80 seconds. So VB of 80 is going to equal 6 times the square root. 80 plus 1 is going to be 81.
Ooh,
so
look how pretty
nice.
that is on a non-calculator.
So we've got 6. Square root of 81 is going to be 9. So 6 times 9 is 54. 54 minus 4 is 50. You guys actually have to do all that work just so you can compare it to rocket A. They ended up being really close to each other. VB is 50. V of 80 is going to be 49. Okay? Now, even though you found all that, you still have to explain and kind of give a reasoning for your answer. So I'm just going to be all over here on part C. Yep, so I would say rocket B is traveling faster at 80 seconds. Okay. Now, you should have some kind of comparison here. So I have a VB of 80 is going to be greater than V of 80. Okay, which was 50 is greater than 49.
And Mr. Honey, change your 8 seconds to be 80 seconds. at time t equals
Oh.
AV.
I guess that 0 is important there. Alright, so a lot of work just for that last part. Alright, A and B are pretty straightforward. You guys definitely need to get A and B right every time. As we talk about points here. Okay. Markers all over the place.
Want green?
None of them work. Yes.
Try that green.
Alright, so in part A, guys, it's only worth 1 point. Okay, we're looking for your answer there. You must have a difference quotient to get that point, though. Part B, you get 1 point for your explanation, describing what the integral from 10 to 70 of v of t dt is. You're going to get 1 point for basically using these values here. Okay, so if you use 22, 35, and 44 in some way, you're going to get a point. And you get a 1 point for your answer. Now guys, you could just do this one line where I use those values and I multiply them each by 20. That counts as basically all of my points in there. Okay? You don't have to get to an exact number. Alright, so for part C, you're going to get 1 point for getting 6 square roots of t plus 1. Okay? So basically they're giving you that point if you integrated acceleration correctly. Okay, you're going to get 1 point for having a plus c here. Remember, this is 2006. Okay, you don't typically get that point anymore. You get 1 point for using that initial condition where VB of 0 equal 2. Okay, so typically they're going to tie those together now. But all you had to do is you got 1 point for your plus c, you got 1 point for using your initial condition. Alright, you're going to get 1 point for finding VB of 80 is 50. And comparing that to 49. Okay? And then your last point, if you had correct units in part A and part B, that would get you another point.
Ooh.
Okay.
And to get the units in B, so this would be hard to earn because you had to get it in all the parts, and to get the units in B correct, and you already had to have A right to get this unit point, you had to say feet over this time frame. Whether you use displacement or distance, it wouldn't matter in this case, but if you didn't say feet, you would have lost this, even if these units were right. If you didn't have your time restated, you would have lost this, even if this was right and you said feet and you had distance or displacement. So that one's kind of hard, but then like the plus C is kind of easy. I don't know.
It all washes out. Alright, well, good luck to you guys. Make sure you pay attention to your units. It'll kind of tell you what to do if you can pay attention to your units.